Once you have finished your static analysis, you will be able to view the results of the static analysis. And the displacement you have analyzed at 45 millimeters thickness of the top plate is around 4.284 millimeters. And you may want to strengthen the top plate so that you can reduce the deformation, and it should not be more than 0.45 as it is specified in the design specification. In order to do that, you may have to run a parametric study. To run a parametric study, you can either create a new study and specify the design objective to be parametric dimension, or you can copy the study you have already done. So right click on it and then just click on copy study. It will take all the parameters you have specified in the first studies, for example, constraints, loads, and contacts. It will take into the second study you have made. Now again, this is a static study. You still need to change it to parametric study. So right click on it, click on edit study properties and change the design objective to parametric dimension and specify the name. For example, this is your parametric study for jacket structure. You can specify any name and leave every other setting as it is, press OK, and now this is your parametric study. In the parametric study, you will have a parametric table. Click on the parametric table and it will appear in the bottom here. Now, in this parametric table, you want to specify a component, that component which you can alter the dimension again and again, and you can have several iterations with different dimensions to view the behavior of jacket structure if you change the dimension of any component from this top plate. So in order to do this, right click on top plate, because top plate is the component you want to alter the dimensions. So show parameters, and in the top plate there are three parameters you can change. You can either change length, width, and height. So let's say if we change the height of the top plate and see whether that will strengthen the component, and click on height and just press OK. Okay, now if you press OK, your top plate will start appearing in component name, and you will have your parametric name, values, and your range of current value and a range of other parameters. So from this, you can specify the amount of dimension, specify the range you are looking for. For example, if my range is currently the top plate height is 45 millimeter, and I want to select this best possible height between 45 to 100 millimeters. And once you have done that, just click anywhere on the screen. It will make 3 iterations of 45 to 100 millimeters. Right click on it and you can generate all the configurations. So you have got 45 to 100 in dimensions in 3 iterations. You can view in the top plate as well. This is currently 45. If you change the slider, this is currently 72.5. If you change the slider further, this is your 100 dimension. So you're going to analyze this top plate with 3 different dimensions in one static analysis. And you can specify the constraint over here. You can right click on it, you can add a design constraint, and you want to reduce the mass, just click on mass and press OK. And constraint value, you want to minimize the mass, so click on minimize, and that's all parametric table set up for you. Now the next step is to simulate, because you have already specified the you have copied the study and it has taken all the design constraints from the previous study. The load is already there, the fixed constraints are already there, and the contacts are already there, so you don't have to specify anything here. However, if you want more than 3 iterations, you can change the number here, or if you want to change the range, for example, I'm looking between 45 to 100, maybe you want to look between 45 to 200, but you also want to stay within your design specification, and you don't want to increase the mass of the jacket structure as well. So Ideal range will be around 45 to 150 or between 20 to 150, and this is where you can analyze how the jacket structure is going to behave. For the time being, I'm just doing 45 to 100. You can follow this, or you can specify any value range of your choice. After this, just click on simulate. Once you click on simulate, the next step is to run the analysis. Click on run. Once you click on run the analysis, it will start computing the results. You need to give it a few minutes to finish the analysis, and once the analysis is finished, you will be able to see the behavior of jacket structure with all three configurations you have made. Once the analysis is finished, you will be able to view the results. And now, as you can see, we are still in the von Mises stress. We will be able to go to the displacement, as this is what we wanted to reduce at, and this iteration is 45 millimeter. At 45 millimeter, we have got the mass of 129 tons for this jacket structure. In this 129 tons, we are getting 4.284 deformation. If we change the configuration, for example, we move from 45 to 72.5, the deformation will reduce to 1.353 millimeters. If that is matching with your design specification, you can use this. Otherwise, you can further increase the thickness and you can move to 100 millimeters of the top plate thick height, and that will give you a deformation of about 0.66, but you are exceeding your design specification. This is 172 tons of jacket structure in total. So you may want to select any height between 72 to 72.5 so that your total mass will be around 150, but at this point your deformation of the top plate is 1.353, so you may want to provide any additional supports underneath this jacket structure to reduce this deformation. You can view the XY plot after running the static analysis by right click on the component's name, or in the parametrics table, right click and click show XY plot, and that will be able to show you the XY plot. So let's say your deformation should be less than 0.45. So if you were getting a value, let's say for the time being, you want your deformation to be lower than 1.571. So using this XY plot, you will be able to figure out which is the optimum height, or what is the optimum height of the top plate for 1.71 thickness. You can draw a horizontal line, then a vertical line to find out what will be your optimum height if you want your displacement to be 1.7571. You can use these XY plots in your reports, and that's how you run a parametric study. You will be able to view different results. You can double click on von Mises stress, and you will be able to view the von Mises stress developed in different parameters. Okay, and that would be it. That's how you run a parametric